motion, let's do a brief review of simple harmonic motion. All simple harmonic motion must satisfy this simple differential equation. X double dot acceleration is equal to negative n squared x. So n is a positive constant. The acceleration is thus proportional to the displacement, but oppositely directed. This equation is usually the most straightforward way to test whether a given motion is simple harmonic with center at the origin. If the center is not at the origin, the equation will just change slightly. You just have an extra x minus c inside. Okay, that will have the center as c. Okay, so what's the solution to this? We see that for simple harmonic motion, it can be modeled by a sine nt plus alpha or a cos nt plus alpha. Okay, so where n is related to the period, and you can also write it in this way. If you don't use this form, you can use this form. They are all equivalent. Okay, so now let's do some equivalent. Okay, good. All right, let's do the first example. Example 1 is a particle is moving in simple harmonic motion. This is shorthand for simple harmonic motion. Acceleration is negative 4x. Show that this is a possible equation of the motion. So what that means is you just have to differentiate twice. So you just have to go x equal to 3 sine 2t, x dot equal to 6 cos 2t, x double dot equal to 12 sine 2t with the negative. And to show you satisfy the acceleration is negative 4x, factorize out the negative 4 times by 3 sine 2t, and this is just equal to x. So you can write that as negative 4x. So to show it's a solution, you just have to show you satisfy the second derivative. Okay. All right, good. So let's continue to do the next one. Before we do the next one, hopefully you still remember this table, the connection between velocity, acceleration, and position. Okay, what's the velocity at the extremes? Think about the spring. What happened to the spring when you get to the extreme? It becomes 0, it stops. And then the acceleration at the extreme will be maximum. So it will be maximum there, minimum there. But in both cases, they have the same magnitude. And because it's opposite, so the upper extreme will result in the minimum acceleration because it's negative n squared x in the opposite direction. Okay, let's look at the velocity at the center. What happened at the center? The speed is max. Okay, which can be positive velocity or negative velocity. On the other hand, acceleration will be 0. Because just imagine the spring is not stretched or compressed, it will have 0 acceleration. Okay, so you can think of it this way. Let's use a different color pen. Okay, good. So you can think of it, to remember this is very easy because you just think of it, it's like noughts and crosses, so you get 0. Actually, let's go like this. Okay, so you can think of it as noughts and crosses. So 0, 0, 0, and center is like a 0. And you can denote extreme by x. X for the extreme, 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 isn't it? So you can remember this table like that. Just noughts and crosses. Okay. All right, good. After we do this, then we go. Now, this is a very important table. Make sure you memorize this. This will be useful in these questions, example 2 and so forth. Let's look at the first example. A particle is moving so that the acceleration is equal to negative 4x in centimeters and seconds. Initially, it is stationary. Let's write it down. When t is 0, v is 0, x equal to 6. Write down the period, amplitude, and the displacement time function. To do this is quite easy because once you see this form, the first thing you can figure out is n. n squared is 4, therefore n is 2. N is always positive, which means the period, which is t, can now be found, which is 2 pi over 2. The period is pi. So work out what pi the period is. And then in addition to that, when you see this differential equation, another pieces of information that can be found is that the center is at the origin. So you can say center equal to 0. And why is that important? Because that will help us to find the equation. Now, it starts off as stationary at x equal to 6. What does that tell you? If it's stationary, you must start from the extreme. In this case, it's the upper extreme. So therefore, because it's stationary, it starts from the extreme. The equation for the displacement is a cos nt plus c. Because it starts from the extreme, it doesn't say stationary, so it must be starting from the extreme. And we know the center is at 0. Therefore, already we know this is 0, this is 2, we found it here, and the period and the amplitude must be 6, because the center is at 0. So 6 must be the amplitude. So 6 cos 2t equal to the displacement time function. Therefore, the amplitude is 6. It will answer the whole question. So we'll look at the clue and then figure out all the information. But once we got the equation, the rest are easy because now you can work out the position at a certain time and the speed and the acceleration by finding the first and second derivative. So we do x dot equals to negative 12 sine 2t and x double dot equals to 12, which is 24 cos 2t. And then what you do is you substitute the time to work out the position at positions and the velocity and acceleration. Okay, let's do that. So substitute, so you do 6 cos 2 pi over 3. This is negative 12 sine 2 pi over 3 and negative 24 cos 2 pi over 3. It has to be in exact form. So thinking back, what's cos 2 pi over 3? Well, 2 pi over 3 is exactly in the second quadrant with a related angle of pi over 3. So therefore, I could work out what cos 2 pi over 3 must be negative cos of the related, and the sine 2 pi over 3 is equal to the positive of the related. And then you can work out what's cos pi over 3. This is half, negative half, and root 3 over 2. And now you can figure out all of this by substituting. So you get negative half here, root 3 over 2 there, and then negative half again. But this time you multiply by 6, multiply by negative 12, multiply by negative 24. And then you end up getting negative 3, 6 root 3, negative 12. Do that have units? Centimeters? So that would be cm per second, cm per second square for acceleration. Yep. Oh, forgot the negative. Yep, you're right. Yeah, it has to be opposite direction. You're right. Thank you. Okay, good. So let me write it in one line. 12 cm per second square. Okay. Now, another thing I forgot to mention, I just remembered, is this. Now, some of the answers you will see like meters per second. Sometimes they write it like this, meters per s negative 1. And same thing for acceleration, they write it like this. And the reason why they write it like this is when you go m over s, that's same as m times 1 over s. which is m s to the power negative 1. That's where the negative 1 comes from. Okay? Alright, so sometimes the answer, they write it like this. Okay, good. Any question? Alright, no question. We'll continue. We'll do the next example. Alright, let's move on. All finished? Okay, let's move on. Next page. We're going to look at the same question again. This is exactly the same as before. Same as before. But this time, I don't want to get in terms of t. I want to get in terms of x. We just did that yesterday. When acceleration are expressed in terms of x, you use the formula. U over dx is half v squared. So in order to find v in terms of x, you have to use this result. And that will give us another equation that you haven't seen before for velocity. Let's work it out. Yep. Half v squared equal to the integral negative 4x dx. Now we're going to get velocity in terms of x, which is negative 2x squared plus c. Like that. Okay, so what do we do now? So what we do is we're going to, when x equal to 6 is stationary. That means v is 0 when x is 6. That will help you to find c. Let's work out what c is. So you put 0 there. 0 equals to negative 2 times 6 squared plus c, which is equal to 36 times 2, 72. So c is 72. And update your formula. So therefore, half v squared equal to negative 2x squared plus 72. And make v squared the subject. And that can be done easily by multiplying both sides by 2. And then you end up getting v squared equal to negative 4x squared plus 144. That's it. That's the formula for, yeah, we got that. Okay. All right, good. So now we have a new formula, v in terms of x, rather than v in terms of t, which will give us other information. All right, once we got that, that will actually make it easier to do certain parts of the question. Before we do so, is it consistent with the velocity and displacement time equation we got earlier? So you got this bit. Remember, we got x is, what was x? X is 6 sine 2t. And velocity equals to negative 12 cos 2t. Does this satisfy this equation? Let's check that out. So let's see whether this two equation works for that as well. So we're going to test. So we're going to write it again. So we're going to write v squared. So left hand side is v squared, which is equal to negative 12 cos 2t squared. And then you square this, which is equal to 144 cos squared 2t. Whereas on the right hand side, you will get, what's the right hand side? That's negative 4x squared plus 444. Okay, negative 4x squared plus 144. Let's substitute the displacement equation, which is this bit. Substitute in there. So 6 sine 2t. Like that. And then we continue, we will get 36 times 4 is 144 sine squared 2t plus 144. And then you say, oh, they don't look the same, but they don't look the same yet. They cos square and sine square are related. We can change sine square into cos square using the simple identity 1 minus cos squared 2t. That, and then we're going to expand and collect like terms. So you get negative 144 plus 144 cos squared 2t plus 144. And then after that, these two terms get cancelled, which you end up getting 144 cos squared 2t. They are now the same. So you write, therefore, left and right are the same. So the equation we got earlier, x in terms of time, velocity in terms of time, also satisfies the velocity in terms of x. All right, good. So now we have actually 5 equations altogether. We've got 5 equations when we analyze simple harmonic motion. Let's write down what they are. So we've got 5 equations. So the 5 equations are the 3 time equations. Let's write down the x equal to 6 sine 2t. The velocity equation, which is negative 12 cos 2t, actually positive. All right, negative before. All right. Oops. All right, okay, but doesn't change the result. Okay, all right, good. And then we're going to write x double dot equal to negative 24 sine 2t. That. We've got the 3 time equation and 2 equation in terms of x, which is the x double dot equal to negative 4x, acceleration in terms of x, and also velocity in terms of x. The question is, which one do we use? That will depend on what you're given. If you're given the displacement, it'll be easier to use these 2 equations because acceleration and velocity are in terms of x. This will be harder to use because you have to work out the time first before you're finding the v and acceleration, which is a bit hard. So you're going to use these 2 equations when you're given the displacement. So therefore, I could answer the question, find the acceleration and velocity when x equal to 3. So you write x double dot, so when x is 3, x double dot can be found easily by doing negative 4 times 3, negative 12. Negative 12. And then for velocity, you go v squared equal to negative 4 times 3 squared plus 144. Using your calc, and then use your calculator. 9 times 4 is 36. I think 108, but let's double check. 144 minus 4 times 9, 108. But be careful, to work out v, you have to go plus or minus. Yeah, okay. And can we simplify it? We can. 108 divided by 36, 3. So 6 root 3. Alright, so we've got all the information. Now we can analyze simple harmonic motion in a more detailed way. There are 5 equations altogether. Which equation you use depends on whether given displacement or time. Okay, alright, so after we do this, we'll now try to come up with a general formula. And then we'll use that general formula to answer a few exam type questions. And then we'll do one more, then you get to do the exercise. Okay, alright. So I'll go to the next page, page 4. Okay, hopefully all done. Okay, good, thank you. Alright, good. Next page. So basically, when you're given the differential equation acceleration in terms of x, you can always find v in terms of x. So any simple harmonic motion, the velocity equation in terms of x always look like this. Let's prove it. See the n and a is the amplitude, n is the stuff related to the period. Now, if we look at the previous example, let's look at this for example. This one here can then be written as, if you take out the 4, you can write that as 4, which is 36 minus x squared, isn't it? Right? So it's in the form of 2 squared, 6 squared minus x squared. So if you compare that with that form, you will get v squared, n squared, a squared minus x squared. That will tell you immediately that the amplitude is 6, as well as the n is equal to 2, right? Which is what we got here. N is 2, A is 6. So we want to prove this general formula for simple harmonic motion. Okay. So how do you prove? We're going to go through the proof, but you may like to write it down first. Okay. Okay, I'll write it down. Okay, good. Let's go on. Let's do a proof. Okay. So how do we prove this? It's the same proof as before. You use the d over dx half v square, which is d over dx half v square, like this. And then what you do is you go half v square equal to negative n square x square on 2 plus c, like you did before. And then what you note that is at the extreme, which is not 0, which is an amplitude, at the extreme, because the center is at the origin, the velocity is 0. That will help you to find c. So you substitute 0 into v, a into x. And then you can work out what c is. C is n squared a squared over 2. That will help you to find. So now you get half v squared equals to negative n squared x squared over 2 plus n squared a squared over 2. Multiplying everything by 2 allows you to cancel the 2 out. So you end up getting v squared. Factorizing the n squared out, you get a squared minus n squared. I think you can quote this formula in the exam, but that's on the formula sheet. I think it is. Actually, they are not. So you have to memorize. They didn't give you that one. All right, so memorize this. So let's get highlighter. So make sure you memorize this formula. Memorize. Okay. All right, so after we do this, we're now going to calculate, using these formulas to calculate the velocity and acceleration when we're given the displacement. So there's the acceleration equation. I'm going to substitute the extreme, the center, and A. So at the extreme, the acceleration will be n squared a. This will be negative n squared a. Whereas at the center of the motion, acceleration is 0. Now, if I substitute negative a in there, let's see what we get. We expect to get 0, isn't it? Because at the extreme, the velocity is 0. And you do, see, right? A squared get cancelled. You get n squared times 0. You stop at the endpoint. And similarly for the other one, you square the negative a, you still get positive, get 0. But on the other hand, at the center of the motion, that's when it's maximum. You can go like this, which is just n squared a squared. So we know that the maximum velocity, or the maximum speed, when you take the absolute value, is na. So you can now work out the maximum speed, max speed, and then this is the maximum acceleration. So we can get all the picture. All right. So now you can see why there's an a squared. That helps you to remember there's an a squared there, because if you substitute the extreme, it should give you 0. So that will help you to remember this formula. Okay, after we do this, we can now summarize the table below. So if the center is at the origin, 0, the extremes are 0, a, and negative a. And the velocity will be 0 at the extreme, but acceleration will be 0 at the center. And in the upper extreme, the acceleration is negative n squared a, that will be positive n squared a. And in the middle, na will be the maximum speed. But in fact, it's plus or minus. All right, good. Now, what if the center's at the C, then the extreme will just change slightly? You go like this. But these things will still be the same. You still get the negative n square a plus or minus na. Yeah. But you don't have to memorize this. You just have to remember this is the maximum speed, maximum acceleration, minimum acceleration, and 0 at these places. And then we need to write down the formula. If the centers of motion is c, then the acceleration will be written like this way, x minus c. And then the velocity, v squared, will be equal to n squared, a squared minus x minus c squared, like that. Okay, so that's all summarized in this table below. This acceleration, everything. Okay, good. So note the difference when the center is not at the origin, you have an extra plus c, extra c there. Okay, note the extra bit. Let me get a highlighter. When the center is at c. Okay, when the center is not at c, you get this. The one above. Yeah. But I think most questions in the exam, the center is at the origin to make the calculation easier. Okay. Finally, we can do it graphically. Okay, let's write down graphically. Actually, yeah, we're going to test why this works. Okay, so acceleration will be x negative n squared x minus c. And then if you substitute c plus a in there, the c get cancelled, you get negative n squared a. The c get cancelled, which is how I got this answer. Okay. N squared. And on the other hand, how do I know velocity is 0 at the end point? So you can check that by doing n squared a squared minus x minus c. So you go, the center will be at c plus a minus c squared, which will become n squared a squared minus a squared, which is 0, as expected. Okay, that will be, oops, the wrong place. Should be pointing to B at the upper extreme. X equal to c plus a. This will be 0. Okay, so it's a lot of complicated stuff. All right, let's get rid of that. Let's write equal. Okay, good. All right, all done. Now let's look at it graphically as well. Okay, there's another line I want to show you. Let's summarize this on the number line below. Okay, so this one here, at the end point, it stops. Okay, that's at a, negative a, 0. Okay, and then what happens is, acceleration at the end point will be negative n squared a. This will be n squared a. And then the velocity, now at the center velocity will be maximum, which is na, or negative na, depends on which direction it's traveling. So on the upper part, it is traveling to the right. So it's traveling to the right, so we go going this way. So therefore the velocity will be n squared, or square root of n squared x a squared minus x squared. That, and then it will still be traveling forward, which you can simplify to be n square root of n squared minus x squared. This will be simplified to be square root n. And then after you reach at the end, it stops. and start to go backward because the acceleration is negative. So start to go back with this equation, negative n square root of a squared minus x squared, and continue to go back, negative n square root of a squared minus x squared. And then after you reach at the end point, it stops again before the positive acceleration increase the velocity to positive, and you go forward again. That's why it goes backwards and forward. And then when you reach the origin, the center, the acceleration will be 0 with the speed maximum. So this is now summarized graphically. Right, so write it down and then have a think. Okay, we still got quite a few to do. Long exercise. Okay, all right, let's move on. Okay, all done? Okay, done. Okay, let's move on. Next question. Okay, let's look at this example. A particle with simple harmonic motion has velocity 15 meters per second when passing through its mean position, basically the center. We're going to make the center 0 to make the question easier to do. So when x is 0, velocity is 15. Find the amplitude of the motion and the acceleration in extreme positions given that the period of the motion is equal to 2. Okay, so when you're given the period, you can work out n because period is 2 pi over n. So therefore, 2 pi equal to 2n, n must be pi. We work out n first. And then what we do need to do is to find the acceleration, find the amplitude, and the acceleration when x is equal to the extreme positions. Okay, so now what we do is we're going to find the amplitude, we can use this formula. V squared equal to n squared a squared minus x squared. We're going to use this formula to work out the amplitude. Okay. Now to do that, we use the fact that n is pi already. Like that. And in order to work out the amplitude, that's when we have to use this information. When x is 0, v is 15. Okay? And then we're going to get 15 squared equal to pi squared, a squared minus 0 squared. That will help us to solve for a. So you get a squared pi squared. You don't even need to use a calculator because when you square root both sides, the square get cancelled. So what would you get? The amplitude is 15 over pi. Now after we get the amplitude, we can work out the question. So what's the acceleration at the extreme position? The extreme position must be equal to the amplitude because we make the center as the origin. Okay? This is the extreme position. So we substitute that into the formula, this, and we know what n is. N is pi. And then we substitute that into the formula to get the expression in the extreme positions. Actually, extreme position will be plus or minus. So let's put plus or minus. 15 over pi times by negative pi square. And that means that it's a times, so you get the pi's get cancelled. So you end up getting plus or minus 15 pi. 15 pi. Yep. That's the acceleration at the endpoint. Could be positive or negative. Okay, good. All done. Got another one. Okay, all right, let's look at the next one. Particle in simple harmonic motion, velocity is root 5 and 2 at these two positions. Let's write it down. When x equal to 1, v is root 5. When x equal to 2, velocity is 2. Yep. And then what we do is we're going to work out the path. So basically, to work out the length of the path is look at the extreme and find the distance between the two extremes. That's the length of the path. And then the period of motion is just 2 pi over n. You have to work out n. So basically, if you work out the amplitude, you can work out the length of the path. Now, they didn't say what the center is, but they say 1 meter and 2 meters from the center of motion. To make it easy, let's make the center of motion 0. So therefore, I could use, because I given information about x and v, the formula to use is this. And once again, to work out n and a is to work out, substitute the x equal 1, v equal root 5 into the equation, and we'll have two simultaneous equations. Let's work out, let's substitute the first bit when v is root 5, x is 1. And then simplify your formula. And then you get this 5 equal to n squared, a squared minus 1. Now, don't have to expand. There's a reason why we don't expand, because it's not a linear equation. There's square involved. It will be complicated. So we're going to call that equation 1. Similarly, we can get the same information with equation 2 by substituting v equal to 2, which you get 4 n squared, a squared minus 4. Okay? So I'll just write it here by doing 2 squared equal to n squared, a squared minus 2 squared. Okay, where x equal to v equal to 2, x equal to 2. Alright, so we have simultaneous equation, and how do we solve it? The easiest way to solve is to divide the two equations, because when you divide, the n squared gets cancelled. Like that. The n squared get cancelled, so you only have a squared left. Then you just use algebra. So maybe what you could do is to cross multiply, and then you get 5a squared minus 4 equals to 4a squared minus 1. Expand and collect like terms. So we expand 5a squared minus 20 equal to 4a squared minus 4. Move this term to the left, subtract both sides by 4a squared. You end up getting a squared minus 20 equal to negative 4. So a squared equal to 16, a equal to 4, where the amplitude is positive. Alright, good. So hopefully you got everything. Amplitude is always the distance between the center and the extreme. Distance is positive. Yeah. Okay. Alright, good. Now you can have negative, but it just means that the equation will have negative a cos nt plus c, etc. So you have the negative a, but the a is still amplitude. It's positive. Alright, good. Alright, continuing on, we're going to find the n. To find n, that's pretty easy. Just substitute into equation 1, a equal to 1. So we get 5 equal to n squared, 4 squared minus 1, which is 15. So therefore, n squared is equal to 1/3. Therefore, n also has to be positive, 1 over root 3. Now, having done all of this, you can now answer part A and B. Now, what's part A? Length of the path, which is, now the extremes are 4 and negative 4, so the length of the path must be 8. So in centimeters, in meters. Okay? And then finally, to get the period, all you have to do is to do t equal to 2 pi over n, 2 pi divided by 1 on root 3. The period is 2 pi root 3. Alright, all done. We've got one more, then we're finished. Alright, hopefully all done. Alright, all finished. We've got one more page. Almost done. Thank you. Okay, next page. Okay, now, simple harmonic motion. So what we're going to do is we'll do this question. So they give you this equation, you have to prove it's simple harmonic. So just refresh your memory. How do I prove something is simple harmonic? To prove something is simple harmonic, we have to show what? No, you have to show this thing. Highlight this. So every time they ask you to show simple harmonic, do this to show it's simple harmonic. That's the only way, regardless what the equation they give you. Okay? But the technique will be different because it's velocity in terms of x, as we learned yesterday. You have to do derivative of half v squared. Halve it first, which is 3 plus 2x minus x squared. After you halve it, you go acceleration is equal to derivative of half v squared, which is equal to derivative of that, which is 0 plus 2 minus 2x. And therefore, the acceleration is, take out the negative 2, x minus 1. So you satisfy that, isn't it? It's in that form. So acceleration is proportional to the displacement about the center 1 in the opposite direction. And then we can use it to find the center, the period, the amplitude of the motion. Okay, so we can find the center already. Center is at 1. Right, center equal to 1. How about the period? Well, this is the n squared, right? N squared equal to 2. N is root 2. So the period is 2 pi over root 2, which you can rationalize to be root 2 pi. Period. Now, we won't be able to work out the amplitude from this. You can only figure out two things, the period and the center, but not the amplitude. So to work out the amplitude, you have to use the velocity equation. And what you need to do is, you have to work out the extreme of the motion. And when x is the extreme, what will happen to v? V is 0 when x is extreme. Let's work out the extreme of the motion. So substitute v equal to 0, and then you solve a quadratic by dividing by negative 2, and you solve it. Which is an easy factorization because all you have to do is to factorize x minus 3x plus 1. Therefore, the extremes are 3 and negative 1. But we still haven't worked out the amplitude because amplitude is not the extreme unless the center is at the origin. The center is at 1. So therefore, if I draw the diagram, if that's the center, then the extremes are 3 and negative 1. Therefore, if you use this diagram, what's the amplitude? 2. Amplitude is 2. So we got all 3. This is a very typical exam question, so make sure you learn the techniques. There's an exercise in the textbook which you can do. And then we've got 2 more bits, then we're done. Maximum speed and find where the particle is when it's half the maximum speed. Okay, alright. So let's do that. So find maximum speed of the particle. And where does it occur? Now, where does the maximum speed occur again? Maximum speed occur at the center. Very good. So what's the center when x equal to 1? Center velocity will be max, or speed will be max. So what you do is you substitute 1 into the formula. So you get x equal to 1, getting you v squared equal to 6 plus 4 minus 2. That gives you 10 minus 2, 8. So maximum speed, maximum equal to 2 root 2 meters per centimeters per second. That's the maximum speed. So maximum speed occurs at x equal to 1. Alright, so the last bit is find where the particle is when the speed is half the maximum speed. So what's x? When v equal to half of the maximum speed. Root 2. So substitute root 2 into v squared. And substitute root 2 there. So lots of quadratic equation, lots of things. You get 2 equal to 6 plus 4x minus 2x squared. Subtract both sides by 2, you get 0. Divided by 2 on both sides. X squared minus 2x minus 2 equal to 0, which you cannot factorize. You can either use the completing square method or quadratic formula. Let's do a completing square. Yep. And then you add 1 to both sides. That will be a perfect square. Yep. Now 6 minus 2 is 4. We'll get rid of that 0 and then divide by negative 2. Thank you very much. X minus 1 squared equal to 3. X minus 1 is plus or minus root 3. That's the end point. So x equal to 1 plus root 3, you will reach the half the maximum speed. That's a long exercise. You could start the exercise now. There's still some time left. I will not teach new things tomorrow. I'll let you catch up tomorrow.